Welcome to Kate and Emma in the morning. Good morning, LaPorte High School. It is a cold, snowing Monday morning today. If you're thinking of going outside, I would highly recommend wearing a jacket and snow pants.
The high this morning is only 15 degrees Fahrenheit with a low of 2. All LaPorte County schools have been closed due to the negative 15-degree wind chill.
I don't know about you, Emma, but I think it's safe to say that most kids are going to be spending their days inside today.
I think so too, which is perfect for us because we have a special program planned for our viewers today.
Before we get to that, let's start off with what happened in sports over the weekend.
The girls basketball team triumphed in sectionals, winning the school's first in over 15 years.
Wow.
The team's final record was an impressive 14 wins to 6 losses.
Do you ever wonder what goes through those athletes' minds as they take that game-winning free throw or three-point shot?
I don't know, but there is actually a lot of math that goes into sports.
Calculus, in fact.
Actually, that segues perfectly into our new segment, Calc Talk.
We've brought in our calculus extraordinaire, Jacob Senny, to teach all you high school students the wonders of how to use calculus in your everyday lives.
So this is what it's like to be on TV. Oh hey, I'm Jake. I have so many exciting things to share with you today, like how to apply calculus in sports like basketball, track, and many others. One super duper thing that you need to know before diving into the magical world of calculus is that differentials talk about cutting things into really, really small pieces, whereas integrals take these small pieces and join them into larger ones. Also, you can't forget that derivatives are the rate of change, also known as the slope.
That's very interesting, But I think we really need to move on. Let's go to politics.
Whoa now. I can stay on topic. But really, they need to know that such things as, you can't pronounce it dx over dt. That's just wrong. You can't do that. You have to be dx dt.
Anyways, let's get back to the program.
So this problem is about our pal Emma Fogelsong. We're going to use some integrals.
Emma Fogelsong's velocity is modeled by v of t equals the square root of 195t, where v of t is in feet per second. She reaches a top speed of 30 miles per hour or 44 feet per second in just 9.929 seconds. How far did she have to run to reach this speed?
We're given v of t equals the square root of 195t. We start by graphing this on the coordinate plane using v of t in feet per second and t in seconds. Have our nice little square root curve here, and then we drew our representative rectangle with v of t and d of t clearly labeled. Shazam. Then to find how far it would take, we go from 0 to 9.929 says the time took her, v of t dt. Going down to here, we plug in v of t from up here, 195t to the 1/2 dt. Take the antiderivative of this right here, and you get 2 over 585 times 195t to the 3/2 plus c. Then you have that mess right there. Plug these two in using the fundamental theorem of calculus. Bada bing, bada boom. Come out, after you plug those in, 291.262 feet. That's how long it will take Emma to get up to speed.
Okay, can we please come back to this? We do at some point have to have a commercial break.
Secant.
I don't know.
Wrong. Cotangent. I don't know. Wrong. Sine.
I don't know.
You should know these. Oh my god.
our commercial break, we're just going to do a little refresher of some flashcards. So, what is the derivative of y equals b to the x? A is correct. Y prime equals b to the x times the natural log of b. Back to the program.
This next problem here uses related rates.
When starting 21 feet apart, how fast must Emma Fogelsong be running to catch Kate Ulmer if Kate is running at 23 feet per second?
The best way to start any problem is by drawing a picture. So here we have Emma, 21 feet apart from Kate. Kate is running in the y direction at dy dt feet per second. Emma is running in the z direction at dz dt feet per second. Next, you list your variables. So first we have z equals 63.569 feet. We found z by solving the Pythagorean theorem of 60 squared plus 21 squared. Take square root of that. There's your sign. Next, bring that down there, right there. Next is dz dt, but that's our variable that we're trying to find, so we're just going to put a question mark there. It works out in the end. Y equals 60 feet, right there. And dy dt equals 23 feet per second, which is Kate's speed. So to solve this, you're going to start with the Pythagorean theorem again, but with both variables. So z squared equals y squared plus 21 squared. You derive this getting 2z dz dt is equal to 2y dy dt. But constants, we all know, equals 0, so we just left that bad boy out. 2, so you plug the variables in next. 2 times 63.569 dz dt is equal to 2 times 60 times 23. dz dt is equal to 60 times 23 over 63.569, since these two 2's cancel out. How convenient. Then dz dt equals 21.709 feet per second, or 14.802 miles per hour. So by using some basic calculus, we found that Emma was running at 21.709 feet per second, or roughly 15 miles per hour.
Well, that's it for us today. Don't forget to bundle
Wait,
up.
no. We said Jacob would have some more time. You have to give Jacob his time.
Back to Jacob.
You guys always leave me out. I never get any screen time. But I still have one more exciting problem for you.
After hitting 7 shots in a row, Jake Senney is said to be on fire. Finding this unfair, Coach Wells decides to pull him out. The rate at which his arm cools is directly proportional to the temperature difference in the arena. Senney's shooting arm reaches temperatures upwards of 480 degrees Fahrenheit, since it is, in fact, on fire. After 5 minutes, it is cooled down to 250 degrees Fahrenheit. If the temperature in the arena is 67 degrees Fahrenheit, how long will it take Jake's arm to cool down to the normal body temperature of 98 degrees Fahrenheit?
We will start solving this problem by listing our variables. S equals the temperature in degrees Fahrenheit, and T equals time in minutes. Next, we will set up the ordered pairs in respect to T and S. After 0 minutes, or when he first comes out, his arm is at 480 degrees, absolutely scorching. After 5 minutes, it is cooled down to 250 degrees. Next, we will set up the differential equation. We know from Newton's law of cooling that the rate at which his arm cools is directly proportional to the difference in temperature in the arena times the constant. So we'll move on. Just by doing some simple algebra, we can rearrange the problem. Do your s's on one side and your everything else on the other. So we have ds over s minus 67 is equal to k dt. Take the indefinite integral of each side, giving us the natural log of s minus 67 plus c1 is equal to kt plus c2. Next, we arrange the constants on one side, right here, giving us c3. Therefore, we have natural log of s minus 67 is equal to kt plus 63. Then we take e to both sides, so we get rid of that natural log over there, because no one wants him. It's like stupid dog. So we have the absolute value of s minus 67 is equal to e to the kt plus c. Then we break up the e's, so we have the absolute value of s minus 67 is equal to e to the kt times e to the c. Then we're going to let e to the c just equal the next constant, plus or minus e to the c. I apologize. Getting rid of our absolute value signs. And then we have s minus 67 is equal to c e to the kt. Then you add 67 to the other side. Right, there's what we're going to work with. S equals c to the ekt plus 67. So now we'll come up here using the same equation from down there, just a little flip-flop up there. We're going to plug in our ordered pair of 0 and 480. So we have 480 equals c to the e k0 plus 67. Subtract 67, e to the 0 is 1, so we have c equals 413. Therefore, s equals 413 e to the kt plus 67. We'll plug in our next ordered pair of 5 250. So 250 equals 413 e to the k5 plus 67. Subtract that 67 over there, then divide by 413, giving us 183 over 413 is equal to k5. Then take the natural log of both sides to get rid of that e. So we have the natural log of 183 over 413 is equal to k5. Then divide by 5, giving us k is equal to 1/5 natural log of 183 over 413. Therefore, s is equal to 413 e to the 1/5 natural log of 183 over 415 t plus 67. 413, my apologies. Now, we plug in 98 because that is the body temperature we would like his arm to be back at, and solve for t, which is right there. So we subtract 67, giving us 31 equals 413 e to the 1/5 natural log of 183 over 413 t. Then, next, we'll divide by 413, giving us 31 over 413 equals e to the 1/5 natural log of 183 over 413 t. Then, we're going to take the natural log of both sides, canceling out the e. So we have natural log of 31 over 413 is equal to this thing right here. It's really long to say, I don't want to say it again. Then we'll divide by 1/5 natural log of 183 over 413, giving us t is equal to 15.907 minutes. So it will take Jake's arm 15.907 minutes to cool down to 98 degrees. So about 16 minutes, he's cooled down. There you go.
Thank you for joining us on this special edition of Kate and Emma in the Morning.
We hope you enjoyed Calc Talk with Jacob.